In this lesson, we will begin the study of polynomials. What are polynomials? Do you know what polygons are? Polygon is a many-sided figure. A polygamist is one who believes in marrying many wives. So poly stands for many. What is a polynomial? A polynomial is an algebraic expression that contains many terms. A polynomial is an algebraic expression of one or more terms. A polynomial may contain one or more variables. Variables can be x, y, a, b, c. Any of those can be a variable. Now, for example, 5x squared plus 2x plus 7 is a polynomial that contains just one variable. It has how many terms? It has 3 terms. There you are. Now, 5x squared y minus 2xy squared plus 2y minus 5 is a polynomial in 2 variables. What are the terms of this polynomial? 5x squared y is a term. Negative 2xy squared is the second term. Plus 2y is the third term. Minus 5 is the fourth term. There are 4 terms for this polynomial. Now, what is the degree of a term? We have discussed that earlier on when we talked about simplifying expressions. We talked about expressions and equations in Unit 1. And then we talked about the degree of a term. What is the degree of a term? Well, if you have only one variable, the degree of the term is the power of that variable. But if you have a term that contains 2 variables, then the degree of that term is the sum of the powers of all the variables. Now look at this term 5x squared y. The power of x is 2, the power of y is 1. Therefore, the degree of this term is 2 plus 1, that is 3. What is the degree of this term, 2xy squared? The power of x is 1, the power of y is 2, the degree of that term is 1 plus 2, that is 3. So the degree of a term is the sum of the powers of the variables in that term. The degree of 5x cubed is 3. There is only one variable there. But what is the degree of 2x squared y cubed? The degree of 2x squared y cubed is the degree of x, the power of x, that is 2, plus the power of y, that is 3. The degree is 2 plus 3, and that is 5. What is the leading term of a polynomial? The leading term of a polynomial is the term with the highest degree. Now, what is the leading term of this polynomial? Now, it is 3x squared y cubed plus 5x to the 4 minus x squared y squared. Which of these terms has the highest degree? The degree of this term, 3x squared y cubed, is 2 plus 3, that is 5. The degree of the term 5x to the 4 is 4. And the degree of the term negative x squared y squared is 2 plus 2, that is 4. And therefore, the leading term is 3x squared y cubed. that has the highest degree. Here, 3 is the coefficient of the leading term. The leading term is 3x squared y cubed, and the coefficient of that term is called the coefficient of the leading term. The coefficient of 5x to the 4 is 5. Now what is the coefficient of negative x squared y squared? The coefficient of negative x squared y squared is a negative 1. That's correct. Now the degree of a polynomial has a degree. What is the degree of a polynomial? The degree of a polynomial is the degree of its leading term. So what is the degree of this polynomial? The degree of this polynomial is the degree of its leading term. The leading term is 3x squared y cubed, and its degree is 5. Therefore, the degree of this polynomial is 5. Alright? A polynomial of one term is called a monomial. A monomial has just one term. Can you give me an example of a monomial? 5x is a monomial, just one term. 7, just the number 7, is just one term. It's a monomial. So a monomial has just one term. 3x squared is a monomial of degree 2. 5 is a monomial of degree 0. Why is it degree 0? Because I can write this as 5x to the power of 0. You see, anything raised to the power of 0 is 1. 5 can be written as 5x to the power of 0. The power of the variable is 0. The degree of this monomial is 0. Alright, a polynomial that contains two terms is called a binomial. Bi means 2. 3x squared plus 2 is a binomial of degree 2. X plus 2 is a binomial of degree, what's the degree of that? Degree is 1. Now, a polynomial containing 3 terms is called a trinomial. A trinomial. 3x squared plus 5x minus 7 is a trinomial. As we move on, we will talk a lot about trinomials. So, trinomials contains 3 terms. 3x squared plus 5x minus 7 is a trinomial of what degree? Its degree is 2. The coefficient of the leading term, what is the coefficient of the leading term of this trinomial? The leading term is 3x squared, and the coefficient of that is 3. Okay. The value of the expression 5x squared minus 6x plus 8 depends on the value of the variable x. If you assign a value to x, then you can evaluate or find the value of the polynomial expression. For example, if x equal to 2, what will be the value of this polynomial? What all we need to do is replace the x by the value 2. Can you do that? It will be 5 times, in place of x I used a 2. 5 times 2 squared minus 6 times 2 plus 8. Now you notice that when I replace x by its value, I replaced it inside a parenthesis, just to indicate that x has been replaced by that 2. Alright, can you find the value of this? 2 squared is 4. 5 times 4 is, so that will be 5 times 4 minus 6 times 2 is 12 plus 8. And that will be 20 minus 12 plus 8. I simplified this. What is minus 12 plus 8? It's minus 4. So that will be 20 minus 4 equal to 16. The value of this polynomial when x equal to 2 is 16. Now, the value of the expression 5x squared minus 6x plus 8 when x equal to negative 1. Can you now do that? Can you find the value of this expression when x equal to negative 1? Replace x by negative 1. Now remember, when you replace x by negative 1, put that inside a parenthesis. Very important. There you are. 5 times negative 1 squared minus 6 times negative 1 plus 8. And now, negative 1 squared is positive 1. That becomes 5 times 1. Alright, what is this? Minus 6 multiplied by negative 1, double negative. Minus 6 multiplied by negative 1 is, well, I haven't simplified that. You see, minus 6 multiplied by negative 1 is the same as minus negative 6. Why? Because 6 multiplied by negative 1 is negative 6. So that will be minus negative 6 plus 8. And that will be 5. What is minus negative 6? Double negative become positive. So that's equal to 5 plus 6 plus 8 equal to 19. It is a very important skill, finding the value of a polynomial for a given value of the variable. Okay, let's do another one. Find the value of 2t cubed minus 3t plus 5 when x equal to negative 2. Replace x by negative 2 and find the value of that polynomial. Well, when you replace x, not this time x, your variable this time is t. So we replace t by negative 2. Remember, when you replace the t by negative 2, put that negative 2 in parentheses. And this is 2 times t cubed minus 3 times t plus 5. Now replace t by negative 2. That will be 2 times negative 2 to the power of 3 minus 3 times negative 2 plus 5. Okay, now tell me, what is negative 2 raised to the power of 3? A negative number raised to an odd power will be a negative number. Negative 2 raised to the power of 3 is negative 8. So this is 2 times negative 8 plus, what is the next term? Minus 3 multiplied by negative 2. So that will be a negative multiplied by negative become positive. Minus 3 times negative 2 is plus 6 plus 5. This is now 2 times negative 8 is negative 16 plus 11. 6 plus 5 is 11. And what is negative 16 plus 11? That is negative 5. The value of 2t cubed minus 3t plus 5 when t equal to, you need to make a correction there, not x. Our variable this time is not x, it is t. When t equal to negative 2, the value of the polynomial 2t cubed minus 3t plus 5 when t equal to negative 2 is negative 5. Okay, let's move on. Write the polynomial 9y squared plus 3xy plus 10x squared in descending order of x. What does that mean? Descending order of x. It tells you that you must write first the term that contains the highest power of x, followed by the term that contains the second highest power of x, and so on. Tell me, of these three terms, which of them has the highest power of x? Is 10x squared. So, when you write it in descending powers of x, you will write 10x squared first, followed by 3xy, and finally 9y squared. Alright, so that will be 10x squared plus 3xy plus 9y squared. What is the degree of this polynomial? Well, the degree of this polynomial is 2. The highest power of the variable is 2. Write the polynomial 5x squared plus 5 minus 2x to the 4 plus 3x in descending order of x. So, what will be the first term you will write? The first term has the highest power, and that is negative 2x to the 4, followed by the next is 5x squared, followed by the third is plus 3x, followed by the last is plus 5. So that will be negative 2x to the 4 plus 5x squared. Remember, when a sign does not come before a number, it is supposed to be positive. So negative 2x to the 4 plus 5x squared plus 3x plus 5 is the descending order for the powers of x. What is the degree of this polynomial? The degree of this polynomial is the degree of its leading term, that is 4. Okay, another one. Find the degree and the leading coefficient of the polynomial 4x squared y cubed plus 6xy to the 4 plus 9xy to the power of 5. Find the degree and the leading coefficient. Well, we got to start by looking at the degree of each term. What is the degree of the first term? The degree of the first term is the power of x is 2, the power of y is 3, the degree of that term is 2 plus 3, that's equal to 5. What is the degree of the second term? The degree of x, the power of x is 1, the power of y is 4, the degree of this term is 1 plus 4, that is 5. What is the degree of the last term? The power of x is 1, the power of y is 5, therefore the degree of the last term is 6. That means this is the leading term of the polynomial, and the coefficient of the leading term is therefore 9. Okay, another one. We will now practice adding and subtracting polynomials. Well, if you know how to add and subtract real numbers, then you know how to add and subtract polynomials. Because if you want to add like terms, for example, if you want to add 5x squared minus 7x plus 8x minus 7x squared plus 8x squared, they are all like terms. Is that right? They are all like terms, we can add them. What all we need to do is add their coefficients. 5 minus 7 plus 8. What is 5 minus 7 plus 8? Can you get that quickly as 6? There are several ways you can do that. Look at this. 5 minus 7 is negative 2. Negative 2 plus 8 is 6. That is one way. Or you can add the positive numbers first. 5 plus 8 is 13. 13 minus 7 is 6. So 5x squared minus 7x squared plus 8x squared is 6x squared. Alright? You know how to do that. We have actually practiced this some time ago. Alright. Polynomial expressions can be added or subtracted using the same rules discussed for adding or subtracting real numbers. That means like terms are combined to simplify a polynomial expressions. You can only add like terms. Now what are like terms? Like terms are terms that have the same degree. Is that right? Well, the same power. Sometimes that may be misleading. Terms that have, for example, if you look here, x squared y cube, 2x squared y cube plus 5x squared y cube. They are both like terms. X squared y cube, x squared y cube. You can add them. That is 7x squared y cube. But can you add these two? 2x squared y cube plus 5x cube y squared. Can you add those two? Are they like terms? No, they are not. These are like terms, but these are not. Okay. For example, x squared y plus 3x squared y minus 12x squared y. They are all like terms. That means you can add their coefficients. I have made the coefficients actually blue. Well, the coefficient in the first case is 1. So what all you need to do is add the coefficients. 1 plus 3 minus 12. What is 1 plus 3 minus 12? It's negative 8. So this will be negative 8x squared y squared. I'm sorry. It will be negative 8x squared y. So x squared y plus 3x squared y minus 12x squared y equal to negative 8x squared y. How about this? 2x squared minus 5y plus x squared plus 3y minus 5 plus x. Well, first of all, we use the associative property of addition to group like things. 2x squared can be added to x squared. Minus 5y can be added to plus 3y. And minus 5 and plus x are on their own. So, we use the associative property of addition to rewrite this. It will be 2x squared plus x squared plus x minus 5y plus 3y minus 5. Now, why did I choose this order? Because I want to place, after the x squared term, I want to place the terms in x, then the terms in y, and then the numbers. The numbers will be at the very end. Is that right? And that's the way we're going to do it. So, we can now add 2x squared plus x squared is 3x squared plus x minus 5y plus 3y. What is minus 5y plus 3y? It's negative 2y minus 5. And this is the result. And you can see it is now written in descending powers of x. That is the normal way we write a polynomial. Okay? Let's do another one. Simplify the polynomial expression x squared plus 3x minus 7 plus 6x minus 5. Now let me ask you, you are adding two expressions. Is there any significance for these parentheses? Well, there is really no significance except that you are told add one expression to another expression. When you add two expressions, you can simply take away the parenthesis. There is no need for the parenthesis. So I can rewrite it as x squared plus 3x minus 7 plus 6x minus 5. And if you noticed, I have used colors there to show how like terms can be combined. X squared is blue. There is no other blue here. That means there are no other terms in x squared. Plus 3x plus 6x, both are like terms. They are both red. Minus 7, minus 5, they are both numbers. They are both green. That means we will now use the associative property of addition to rewrite this as x squared plus 3x plus 6x minus 7 minus 5. Group like terms together. Now you can add them. That will be x squared plus 3x plus 6x is 9x. Minus 7 minus 5 is negative 12. Alright, now comes a very important concept. Simplify 4y squared plus 9y minus 1, a quantity, minus 2y squared plus 10. Now, is the parenthesis significant this time? The answer is yes. Why? Because we are subtracting a quantity. When you subtract a quantity, that quantity should be always in a parenthesis. Now, the first quantity, the parenthesis is not significant. We can simply take it away. But the second parenthesis is very significant. When you subtract a quantity, you see, look at this, subtract a quantity, enclose that quantity always in the parenthesis. And then remove the parenthesis by distributing that negative sign. And you know that distributing a negative sign means distributing a negative 1. We have done that several times. So let's write this. First, you don't need the first parenthesis, and what we're going to do is distribute the negative sign. What does it mean, distribute the negative sign? It's the same as distributing a negative 1. So multiply the negative 1 by 2y squared. That will be negative 2y squared. And then multiply the negative 1 with the 10 to give you negative 10. So that will be, now I have used parenthesis again for the first, but you don't need it. Now, so I just remove that parenthesis, but come here, distribute that negative 1. Negative 1 times 2y squared is negative 2y squared. Negative 1 times positive 10 is minus 10. You see how that significantly changed the situation. Alright, now we have distributed the negative 1 into these two quantities. We are now going to collect like terms. Now again I have used colors there, and that's equal to 4y squared minus 2y squared, they are like terms, plus 9y is on its own, minus 1, minus 10, they are both numbers and they will be at the end. Okay, now add like terms. 4y squared minus 2y squared is 2y squared, plus 9y minus 1 minus 10 is minus 11. Okay, let's do another one. Well, that's a pretty big one. Simplify the polynomial expression negative 1/3 x cubed plus 1/4 x squared y plus 8xy squared plus negative x cubed minus 1/2 x squared y plus xy squared. Well, do we need the parentheses? In this case, we are adding. This is a plus. You see, distributing a plus 1 will not change anything. Therefore, you don't need the parenthesis. We can actually take the parenthesis away. Look at that. I have taken the parenthesis away because we are adding. On the other hand, if this were a subtraction, then you have to distribute that negative sign. Then only the parenthesis will be removed. Okay, what do you do now? Collect the like terms together. Can you identify like terms? Negative 1/3 x cubed minus x cubed, they are both like terms. Then 1/4 x squared y and negative 1/2 x squared y, they are both like terms. Any others? 8xy squared, xy squared, they are both like terms. So we will now use the associative property of addition to group like terms together. That will be negative 1/3 x cubed minus x cubed plus 1/4 x squared y minus 1/2 x squared y plus 8xy squared plus xy squared. Well, this time, in order to simplify these, how do we simplify? Negative 1/3 x cubed minus x cubed. Well, we got to use our expertise of using or adding fractions. Now look at the way I'm going to show you how to do this. Alright, how to add the x cubed. Watch the step I'm going to take. I'm going to write this as negative 1/3 x cubed is the same as negative x cubed over 3. Is this right? Do you understand this? Yes, this 3 belongs to the denominator. So negative 1/3 x cubed, I made the numerator negative. I told you, when you want to add fractions that are negative, make the numerator negative. That will make it easy for us. So negative 1/3 x cubed is written as negative x cubed over 3 minus this x cubed I'm going to write minus x cubed over 1 minus x cubed over 1. And look at the way I'm going to do that. That will be 3 is the common denominator. And now, what's the method of constructing our numerator? This will be 3 divided by that denominator 3. 3 divided by 3 is 1. And 1 multiplied by negative x cubed will be negative x cubed. So I write negative x cubed there. Alright, follow that up with the minus sign, this minus sign. So this minus sign we have now used. 3 divided by 1 is 3, and 3 multiplied by x cubed is 3x cubed. So that will be minus 3x cubed, and that's equal to negative 4x cubed on the top and 3 at the bottom. So when you add negative 1/3 x cubed minus x cubed, this is what you get, negative 4x cubed over 3. And now you can take this negative and give it to the whole number. Okay, in the same way we will add these using the same principle. Alright, let me see if you understand my step. So I got this as 3 common denominator, 3 divided by 3 is 1, 1 times negative x cubed is negative x cubed, minus the denominator here is 1, 3 divided by 1 is 3, 3 times x cubed. So this is negative x cubed minus 3x cubed over 3 plus. Look at how this is done. The common denominator of 4 and 2 is 4. And now let's make the numerator. 4 divided by 4 is 1. And that 1 is multiplied by x squared y. Remember, x squared y is the numerator. Minus 4 divided by 2 is 2. And 2 times x squared y. The numerator will be 1x squared y minus 2x squared y all over 4. Well, these will remain as they are. 8x squared y plus x, 8xy squared plus xy squared. What is that now equal to? This will be negative x cubed minus 3x cubed all over 3 plus x squared y minus 2x squared y all over 4 plus 8xy squared plus xy squared. Let's now add these like terms. That will be negative 4x cubed over 3 plus x squared y minus 2x squared y is a negative x squared y. Is that right? The coefficient here is 1. 1 minus 2 is negative 1. Therefore, this is negative x squared over 4 plus 8xy squared plus xy squared is 9xy squared. And what you now need to do is, this negative sign now belongs to the whole term. This is now negative 4x cubed over 3 and plus negative, that will make this whole thing negative, minus x squared y over 4 plus 9xy squared. Well, if you want, you can make a small modification there, and that is, this is the same as, watch this, this is the same as negative 4/3 x cubed minus 1/4 y, 1/4 x squared y plus 9xy squared. You can write them specifically with the coefficient. You see, negative 4x cubed over 3 is the same as negative 4/3 x cubed, and minus x squared y over 4 is the same as minus 1/4 x squared y plus 9xy squared. Okay. If you can do one like this without making a mistake, you have mastered this process. Alright, so try and go through this one more time. Another one. Simplify the polynomial expression 3a squared b minus 6ab plus 5b squared, that is the first expression, minus, in parenthesis, the quantity 4ab minus 6b squared minus 5a squared b. Again, you notice that the first quantity, there is no need for the parenthesis. But the second quantity is subtracted. So the second quantity has to be inside the parenthesis, and you need to now distribute that -1. The negative sign outside the parentheses stands for a -1. Now this is where most of you make mistake. This -1 needs to be distributed. Can you distribute in your mind? -1 multiplied by 4ab will be minus 4ab. And -1 multiplied by negative 6b squared. The sign of this is negative. Negative times negative is positive. That will be plus 6b squared. And a -1 multiplied by a negative 5a squared b will become positive 5a squared b. You see, there is an easy way to remember this. An easy way to distribute a -1 outside a parenthesis. When a -1 is distributed, every term inside the parenthesis will change sign. When you distribute this -1, this plus 4ab will become minus 4ab. This minus 6b squared will become plus 6b squared. This minus 5a squared b will become 5a squared b. So when you distribute a negative sign, each term inside the parenthesis will change sign. If you keep that in mind, it'll be very easy. Now what does it mean, remove the parenthesis? Well, there is no need for the parenthesis for the first term, first quantity. And removing the parenthesis in the second case means distribute the negative sign or -1. So the first quantity remains as it is, 3a squared b minus 6ab plus 5b squared. And I distributed the -1. It becomes minus 4ab plus 6b squared plus 5a squared b. Well, what we now need to do is identify like terms. I have colored these like terms, so we combine like terms together. That will be 3a squared b plus 5a squared b, they are like terms. Minus 6ab minus 4ab, they are like terms. Plus 6b squared plus 5b squared plus 6b squared. Alright, let's now add those. 3a squared b plus 5a squared b will be 8a squared b. Alright, can you add this in your mind? Minus 6ab minus 4ab. Adding two negative quantities, you simply add them together and use the negative sign. Minus 6 minus 4 is minus 10. So this will be minus 10ab. Well, of course, this is simple. 5b squared plus 6b squared is 11b squared. So that will be 8a squared b minus 10ab plus 11b squared. That is the answer there. Okay, let's go on to another one. Simplify the polynomial expression. Now watch this carefully. 5w minus 6w squared minus bracket parenthesis 3w minus 2w squared minus parenthesis 4w plus w squared parenthesis end bracket end. Now, where do we start the process of simplification here? If you remember your order of operations we did long ago, not very long ago, first we need to distribute this parenthesis. So, distribute that -1, and in doing so, if you notice inside the square bracket, there is no need for these parentheses. So we can remove these parentheses, they are not doing any useful purpose, and then distribute the -1 so that these parentheses also will go. So remove the parentheses first. What does that mean, remove the parentheses? Inside the square bracket, the first quantity does not need the parentheses. The second quantity, the parenthesis gets removed when the negative sign is distributed. Now, what did I say will happen when a negative sign is distributed inside a parenthesis? Every term inside the parenthesis will change sign. 4w will become -4w, plus w squared will become -w squared. Alright, let's do that. All these remains the same. I simply remove those parentheses from the first quantity, distribute -1. -1 times 4w is -4w. -1 times positive w squared is -w squared. And now we simplify inside the square bracket. We collect like terms inside the square bracket. What are the like terms inside the square bracket? Look at this. 3w minus 4w. They are like terms we can add. Minus 2w squared minus w squared we can add. Alright, so that will become, tell me, what is 3w minus 4w? 3 minus 4 is -1. 3w minus 4w is a -w. And -2w squared minus w squared. -2 minus 1 is -3. -2w squared minus w squared is -3w squared. So we simplified the quantities inside the square bracket. What is the next thing to do? Next, we remove the square bracket by distributing that negative sign. This negative sign needs to be distributed inside the square bracket. Now, what did we say? What happens to inside the bracket when a negative sign is distributed? Each term will change sign. When this -1 is distributed, this -w will become positive w. This -3w squared will become positive 3w squared. Alright, let's do that. Remove the square bracket. It means distribute the -1 into the square bracket. That is, these two will remain. They are 5w minus 6w squared minus 1 distributed to -w. Minus 1 times -w is plus w. Minus 1 times -3w squared is positive 3w squared. And now look for like terms one more time. 5w can be added to w, and -6w squared can be added to positive 3w squared. Okay, that will be 5w plus w is 6w, and minus 6w squared plus 3w squared minus 6 plus 3 is -3. That will be -3w squared. Now, when you write final expression, it must be written in descending powers of the variable. So we will rewrite it with negative 3w squared first, followed by plus 6w, so that you got the powers in the descending order. Alright? I hope that is clear. Now, I want you to go back and do this one more time, each step, and practice what happens in each step. Okay. Subtract 4x minus 11 from 7x plus 3. You remember we talked about this. Subtract 7 from 8. What does that mean? Subtract 7 from 8 is 8 minus 7. Now, subtract this quantity from this quantity means this quantity minus that quantity. That is the way you must understand it. So, subtract A from B means B minus A. So, subtract 4x minus 11, the quantity 4x minus 11 from 7x plus 3 means 7x plus 3 minus the quantity 4x minus 11. Now, why didn't I use a parenthesis for 7x plus 3? I don't need to. It makes no difference. But the quantity that is subtracted needs to be inside the parenthesis. Why? If you don't, then the signs will not agree. Subtracting a quantity means you need to distribute that negative inside that quantity. So, 7x plus 3 need not be in parentheses. But after the negative sign, whenever you subtract a quantity, after the subtraction sign, the quantity must be inside parentheses. And then you need to distribute that negative to remove that parenthesis. Okay, so now you have 7x plus 3 minus parenthesis 4x minus 11. What is the next step? Remove the parenthesis. What does that mean? It means distribute the negative 1 inside the parenthesis so that the parenthesis will go. Now remember, when a negative 1 is distributed into a parenthesis, the terms inside will change sign. So that becomes what has... There you are. So that will be 7x plus 3. Distribute negative 1 into 4x. That will be minus 4x. Distribute negative 1 into negative 11. Negative 1 times negative 11 is positive 11. And now combine like terms. 7x minus 4x is 3x. Plus 3 plus 11 is plus 14. So the answer there is 3x plus 14. Now, let me give you a warning. I have seen very many times students making mistake in here. Subtracting a quantity from another quantity is this minus that. Always be very sure about that. Another one. Subtract 0.2a squared minus 3.98 plus 26.4. Subtract this quantity from this quantity, negative 4.2a squared minus 9.6a. So which of these is going to be to the left? Subtract this quantity from this. So that will be on the left, then minus, remember after the subtraction sign, the subtracted quantity must be inside parenthesis. I haven't given you the parenthesis here, but when you subtract this quantity, that must be enclosed inside the parenthesis. Very important. So this can be now written as this quantity minus this quantity. That's the way we write it. And after the minus sign, the subtraction sign, you have the quantity subtracted inside parentheses. What is the next step? Distribute that negative. Alright? So the polynomial that is subtracted must be inside the parenthesis. Now we remove the parenthesis by distributing the negative 1. And that will be negative 4.2a squared minus 9.6a. That will remain the same. Negative 1 times 0.2a squared is minus 0.2a squared. Minus 1 times negative 3.9 is plus 3.9a. And negative 1 times positive 26.4 is minus 26.4. Alright? When a negative sign is distributed inside a parenthesis, each term will change the sign. Look at this. Positive 0.2a squared became negative 0.2a squared. Negative 3.9a became positive 3.9a. 26.4 became negative 26.4 by distributing the negative sign. Very important skill you must know. Now we combine like terms. Negative 4.2a squared minus 0.2a squared, that can be combined. Minus 9.6a plus 3.9a can be combined. Can you do that on your own? So negative 4.2a squared minus 0.2a squared. What is negative 4.2 minus 0.2? That would be negative 4.4. Okay, what is this? 3.9a minus 9.6a. Well, work it out. What is 3.9 minus 9.6? Alright, so this will be negative 4.4a squared plus 3.9a minus 9.6a is minus 5.7a minus 26.4 is that result. Okay, so the skill of dealing with polynomials is very similar to dealing with real numbers. Once you know how to deal with adding and subtracting of real numbers, you can do the same thing with polynomials. Let's do another one. Add, this time you add two expressions. Negative 2x squared minus 4x plus 12 and negative x squared minus 2x. Add the two expressions. Now that creates no problem. You can write it like this. Add this quantity is added to this quantity. Now I used the parenthesis for that quantity, but actually the parenthesis is not required. Why? Because distributing a positive sign will not change anything. So this one now, removing the parenthesis means simply remove the parenthesis. This one, adding a negative will remain negative. So that will be negative 2x squared minus 4x plus 12 minus x squared minus 2x. Now add like terms. That will be, combine the x squared terms. Negative 2x squared minus x squared is together. Minus 4x minus 2x are together, plus 12. And now you can combine them. That will be negative 3x squared minus 6x plus 12. That's fairly simple. Okay, I think we have discussed enough skill on adding and subtracting polynomials. In the next lesson, we're going to look at multiplying polynomial expressions. Alright? I look forward to that. Polynomials are a rather interesting class of algebraic expressions, and we're going to deal with a lot of those as we move on. Alright, I will see you for the next lesson later on. Subtracting